This is a continuation of practice problems in the analysis of an AC network. Problem number 7. An AC network is shown here in the form of a block diagram. Our task will be to find the total load in watts and vars and volt amperes in this AC circuit. Recall that watts, vars, and volt amperes are all dimensionally the same, that is, the product of voltage and current. However, we use the designators of watts, W, to represent real power, or instantaneous or average power, volt amperes reactive, vars, to represent reactive power, and volt amperes, VA, to represent complex or apparent power. These show power triangles for AC circuits. Power triangles are drawn in the following standards. Inductive reactive power is drawn in the plus J direction, and capacitive reactive power is drawn in the minus J direction. By applying the Pythagorean theorem to either of these power triangles, volt amperes may be calculated. That is, S squared is equal to P squared plus QL squared, or QC squared. This equation can be applied to any circuit. The net reactive power supplied by the source to the RLC circuit is the difference between the positive inductive reactive power and the negative capacitive reactive power. QX is equal to QL plus QC, where QX is the net reactive power in vars. When solving for the total real power, the arithmetic addition can be used to find the total real power. The total power PT is equal to P1 plus P2. In our problem, with the total real power delivered and consumed is 200 plus 500, which adds up to 700 watts. Solving for the total reactive power, QX, which is equal to QL plus QC, which is 1200 plus the quantity, or minus 500. Now remember that QC is capacitive, so the reactive power, which is negative, therefore the total reactive power is 1200 minus 500, which equals 700 vars. Because the total reactive power is positive, the circuit is inductive. Solving for the total volt amperes, S, we get the square root of the sum of P squared plus Q squared, which is the square root of 700 squared plus 700 squared, which is 989.8 volt amperes. I have drawn the actual power triangle here. Before closing off, I wanted to bring you in on a Super Prime Day Encore sale, for which there is only 3 days left. Jackery is offering several of their components for up to 65% off. These are the best essential home backup picks. You can take advantage of this super sale by going to this web address. And even if you miss the deadline, this web address will take you to They're excellent products that you can satisfy your home backup power needs.